chain of events, cause and effect. We analyse what went right and what went wrong, as we discover that many outcomes can be predicted, planned for, and even prevented. I'm John Chidgey, and this is Causality. Causality is part of the Engineered Network. To support our shows, including this one, head over to our Patreon page, and for other great shows, visit engineered.network today. Flint, Michigan. Some people described what's happened and is still happening with the water supply in Flint as being a case of a first world country with a third world water supply. It's a bit harsh, but the fact is we all need water. Before we get into exactly what happened at Flint, and as I say, what is still happening, I need to start a little bit about the importance of water. I've worked on numerous water treatment plants, at dams, freshwater pipelines in my career. And if there's one thing I've learned, it's that you have to take it seriously, very seriously. Clean, fresh, safe drinking water is the cornerstone of life. And in order for our basic needs to be met, in order to survive as an animal, we require oxygen, water, and food, in that order of importance. With oxygen, without it, our brains will suffer permanent damage within minutes and will die within an hour or so without oxygen. Water's next. We die without water after 3 days on average, although some have been shown to survive up to 12 days without water, but that's pretty unusual. That's water deprivation, of course, but bad water can cause all sorts of illnesses, and it may not kill you as quickly, but it can still kill you. For water, we can survive, but without food, we can go for about 3 weeks on average, provided we have water. And obviously, those with more storage, if you'd like, will last longer than those without. And of course, local conditions will affect the end result. Assuming that someone doesn't come along to the planet and suck up all of the air, then it all starts with water. Now, in my observation, people have become accustomed to having it. It's always there. It's always clean and it's safe to drink. And most people in Western culture haven't walked miles to the nearest well and then brought that water home, or even pushed and pulled a lever up and down to pump water out of a well, or ever owned a rainwater tank. Water just comes out of the tap, or faucet, depending on what country you live in. And when I was a kid, bottled water wasn't even a thing. Now, town planners knew that running water from the tap was a critical part of our society, 100, if not hundreds, maybe even thousands years ago. They built water towers to maintain water pressure. They built dams to store rainwater. They built barrages across flowing rivers to separate tidal flows. Built water treatment plants to ensure the water was safe to drink, and built huge, enormous networks of pipework under the ground into people's homes to ensure they had fresh water to drink, clean and wash with. The people that we put in charge of our drinking water supplies take it very seriously. They have done for many years and they will for years to come. But in many ways it's become a commodity, one that's being traded and bargained for, despite the fact it is technically an essential service that we all require. It's being outsourced. The dollar costs are getting driven down all the time. And when you're in management, the need to cut down those costs to get the cheapest bid in to run the treatment plant or whatever it might be, well, that pressure can lead to compromises. Sometimes there are different water sources that you can choose from, some cases not. But not all sources are created equally. Some will come from aquifers of varying degrees of quality, others from dams, others from rivers, and each will have their own unique water quality profile. Some will require more treatment than others, and some require long pipelines to bring them to where the water is actually needed to be used. And all of this will affect the final cost, the cost of the water, and a cheaper source up front may not always be cheaper in the end once you've treated it. But in the search for cutting costs, they cut corners, and ultimately, in the case of Flint, they cut one corner too many, and things started to go wrong. So let's talk specifically about Flint, Michigan. Now, for many years, the water supply was sourced from the Detroit Water and Sewerage Department, but they were considered to be too expensive, and the city was in tough times and looking for alternatives that were cheaper. On April the 16th, 2013, the city decided to sign up with the Carignan Water Authority, KWA for short. And they decided it would be cheaper to build a pipeline from Lake Huron to Flint to source their water from there. The proposal and recommendation came from the Infrastructure and Development Director Howard Croft and the Utilities Administrator Doherty Johnson III. It was signed off by the then Emergency Manager Ed Kurtz. The pipeline was due for completion during 2016, this year. However, the agreement with Detroit Water was up for renewal at that point. Now, Detroit offered a short-term contract to see them through until the pipeline was ready, but the cost was considered to be too high. And the Flint officials decided that a temporary water source would be used instead. And that water source that they chose was to be the Flint River. The water source for Flint was switched in March of 2014. Some customers in Flint could tell the difference immediately with the taste and the NDS, that's non-dissolved solids, as well as the odor being very different from the Detroit water. And it was on the 8th of September 2014 that Flint city officials advised their customers to begin boiling their water after several cases of Escherichia coli surfaced in the community. Of note also, on the 13th of October, General Motors issued a notice to stop using the water supply from the council because it was corroding steel components in their manufacturing plant. Further testing of the water quality within a few weeks of that determined that there were dangerous levels of trihalomethanes, TTHM for short, present in the water, and they're a byproduct of overchlorination. In January of 2015, news leaked from Virginia Tech University. In their studies, they detected unsafe levels of lead in water samples they'd taken on campus. It was initially thought to be an isolated case. However, Virginia Tech continued to investigate irrespective. On the 10th of February 2015, Veolia Water were engaged to independently assess the situation. Veolia run multiple water treatment facilities around the world, including some here. On the 18th of March 2015, they delivered their report recommending $3 million US be invested with improvements to the water treatment facility. There was no mention of lead levels at that time. By September, the same Virginia Tech team that had earlier in the year reported lead detected at their campus had sampled water now from 252 individual premises, and they found that the city's 90th percentile lead level was in fact 25 parts per billion, and this exceeded the 15 part per billion EPA action threshold. On the 15th of September 2015, these figures were officially released to the public, and there was somewhat of an outcry. Further tests over subsequent weeks found that several end customer premises had lead levels 3 times that legal limit. On the 2nd of October 2015, it was officially acknowledged and an action plan was released to address the problem by Flint officials. Further blood testing of the children from Flint showed levels of 2.5% before the switch, rising to 6.3% approximately 1 year after the switch of water supply. 3 major schools were some of the highest lead level areas that were measured in Flint. One school tested at 6 times the legal limit. On the 16th of October 2015, Flint officials switched the water back to Detroit Water. And on the 10th of November 2015, the United States Environmental Protection Agency became officially involved. On the 14th of December that year, a state of emergency was declared in Flint, Michigan. At this point in time, it seems like a very crazy idea that a country like America, with so many people, access to all the technology that they could ever want, could have something like this happen. It's an interesting chain of events that led us to the lead poisoning and to where we are today. And understanding exactly where it went wrong, I need to explain a few things first. I guess whenever I looked into this, I had to ask, where was the chemist? Where are the engineers? The corrosion specialists? See, corrosion control plans, or CCPs, they're standard pretty much for all water treatment systems I've ever seen, that I've ever worked on, and frankly, not just in Australia, but around the world, including America. But Flint didn't have one. Now, I'd suggest maybe they didn't think they needed one, since their water, when they were sourcing it from Detroit at least, didn't have any adverse effect on the reticulation system. I'm not sure. It seems bizarre to me that they wouldn't have one. Certainly, in the end, lead was the biggest problem, but like I said, it was like Flint's issues are like pulling a thread, and all the actions and reactions create the next set of actions and reactions, and the worst problem of all ended up being the lead. But where did it go wrong? So the EPA's lead and copper rules require water utilities serving more than 50,000 people to establish a plan to monitor and control corrosion. Now, that, in my opinion, even that number is ridiculous. There should be a CCP for any sized water reticulation system, not just 50,000. The excuse given by the Flint officials was that they'd mistakenly suggested they were set up for a city of 50,000, not 100,000, which was the actual population of Flint. In a statement on the 10th of October 2015, that was when Howard Croft resigned. To me, that's such a ridiculous cop-out, I can't get my head around it. Anyway, irrespective of that, how do we protect pipes from corrosion in non-Flint reticulation systems? Well, what I've typically seen used is ORP, which is an abbreviation for orthophosphate. We add orthophosphate at the water treatment plant, and like plants I've worked on, and it's used as a corrosion inhibitor. Now, since Detroit had been adding that for years into the water supply and then pumping that out to Flint for nearly 50 years, their own water treatment plant didn't have any ORP dosing system installed. Well, they didn't need it until they switched. Now, the ORP, how it works is it creates a thin film, and they call it a passivation layer, and it chemically insulates the pipe wall from the chlorine disinfectant. I mean, I know it's not technically an insulator. I'm an electrical engineer, so I prefer to think of things like an insulator, okay? But it's a protective layer. Think of it like that. That separates the chlorine that would otherwise react with the metal, be it iron, lead, or copper, inner walls of the pipes. Now, many countries around the world still have lead pipes in use today, and millions of people are dying from lead poisoning. So it can't be that simple. The thing with ORP is it's always under attack, just from particulate erosion, so suspended particles, not dissolved solids, but suspended particles as the water travels through the pipe. Kind of like a very gentle sandblasting and erosive effect. So, we keep dosing it to ensure there's a healthy protection layer. But it's not just particulate erosion. The chemistry of the water will deteriorate it as well. And without any phosphate at all in the water, the passivation layer is ever so gradually eroded as time passes. The water from the river, in addition to that, was a more acidic pH than the water from Detroit. And rather than correcting it, it was allowed into the reticulation system, which further dissolved the protective layer, slowly released the pipe's metal back into the water supply. Quick lesson on pH. pH of 1 is highly acidic and 14 is highly basic. 7 is what we refer to as a neutral solution. In water treatment, we always keep the pH a minimum buffer amount on the basic side of neutral. 7.5 to 8.5 pH is typical enough. The amount of acid-lime dosing in place for pH correction is relative to the water source and the cost to dose in order to trim the pH. We dose with one chemical to treat one problem, it will affect the pH usually. So we'll trim with another chemical to bring the pH back again. Now, when Flint switched from Detroit's water, it went from about 8, a pH of 8, in December of 2014, and it slid down to about 7.3 by the August of 2015. And that's very odd because they should have been trimming that pH to a set point. They should have a target value, either fixed rate, flow pace, however they want to dose. But irrespective, they should have had some kind of a target. But it says to me that either they weren't trying to trim it, or they didn't think it was a problem, or it was a fixed rate dose, and they weren't paying much attention. I guess that's probably worse if they weren't paying attention. Irrespective, it was not controlled by any stretch of the imagination. Now, chlorine concentration is another one that's worth considering as well. The Detroit's water's average chlorination, or chlorine concentration, I should say, was 11.4 parts per million. That was in 2014 as it arrived at the plant. However, in August of 2015, it was measured in Flint at 85 parts per million. It's no wonder it smelled rather strong concentration of chlorine. Now, that occurs to me that it was probably an overcorrection, and that was a reaction to the E. coli contamination problem from mid-2014. So what they did is they increased their dosage of ferric chloride, which is a coagulant for organic particulates, and that makes them flocculate and makes them easy to remove. But this increased the chloride concentration as a direct result. Flocculation is simply a process whereby smaller suspended solids will clump together and group, allowing them to be more easily filtered out by sand filters or different kinds of filters. So as you add more ferric chloride, you then need to trim something else. So you add one thing, you need to trim another. The water chemistry, it's not as straightforward as you'd like it to be. Now, multiple studies showed that the corrosive rates of lead increase when chloride-sulfide ratio is greater than 0.58. Now, to compare, Detroit's water had a ratio of 0.45, which was less than that. But the Flint River treated water, at its worst, was measured at 1.6, that ratio, 1.6 more, nearly 3 times as much. Not just a bit worse, a lot worse. The worst part of it for me, though, is that the first sign of trouble was there was discoloration of the water in mid-2014, only a few months after they switched to the river water source. Now, that was caused by the breakdown of the passivation layer that were previously discussed. And that discoloration was actually caused by rust. The iron pipes were the first ones to show damage. And that was at rust coloration. That should have been the first sign that something was seriously wrong. The thing that a lot of people don't realize about chlorine, though, is that chlorine is essential to protecting us from bacteria. And there's only a very, very small number of bacteria and viruses in existence that can survive when dosed with chlorine, which is why it's used for water disinfection. It's very effective. Chlorine concentration, though, it deteriorates over time. They call it the chlorine residual, as in residual level. And you can't stop it. And we measure free chlorine levels in water post-treatment to ensure that the minimum is retained at the outlet of the water treatment plant, so that by the time it reaches your place, it's traveled through the pipelines, reservoirs, towers. It has to be a minimum chlorine residual present at the delivery point. And when I say delivery point, I mean the tap or the faucet, whatever you want to call it. So we want that chlorine to be in the water, because if it isn't, it can't kill the bacteria that it could pick up along the way as it passes through the whole reticulation network on its way to your door and to the point of delivery. The problem was, once the passivation layer had eroded, the chlorine residual in the lines, it began to react with the metal directly, specifically the iron in this case, and that reaction started to consume a lot of the chlorine that was in the solution. When I say the solution, I mean the water, of course. And that meant that the E. coli bacteria could grow, leading to people getting sick, because the chlorine that was supposed to kill it off and keep it at bay had been consumed by a chemical reaction with the iron in the pipe, because there was no passivation layer. So what did the Flint officials do at the water treatment facility to fight that? They added more chlorine. So that then accelerated that reaction with the iron and the lead, and that released more into the water system. So we know lead is nasty stuff. Something Roman reference, right? I mean, the debate goes on if there was actually a cause of illness in Roman times, but we well know the effects of lead poisoning from modern medicine. Some of the symptoms include partial or full blindness, can cause hallucinations and hearing loss, slurred speech, kidney failure, which leads to dialysis, insomnia, depression, short-term memory loss, infertility, tingling pains in the fingers and toes, constant fatigue. The list goes on and on. It's actually pretty terrible. But the effect of lead on children in particular, it's horrible because it leads to learning difficulties, permanent, lifelong disabilities. Now, we don't use lead pipes anymore, but in 1990, the American Water Works Association estimated there were millions of lead service lines in the United States alone. The obvious question is, why do we use metal pipes at all? They're cheap, they're easy to work, they last a long, long time, basically. Polymer pipes, or poly pipes for short, they're great, but they're a relatively new thing, and they don't have the same longevity. Retrofitting pipe work with non-metallic pipes is normally done on a failure replacement basis, because replacing all of that infrastructure would bankrupt most local governments. It always comes back to money, always. So even now, they're back on Detroit water. It could take many, many years to repassivate or reline the pipes, however you want to think about it. And as this is being recorded, some locations in Flint are still seeing unacceptable levels of lead in their water at the delivery point. I wonder also, though, just how rigorous water testing is in other parts of the country, and the world for that matter, as a direct result of this incident. You can never, ever take your eye off the ball, not for a second. So what actually went wrong here, besides the chemistry of the water? Who really is to blame? And what do we learn from this? Well, I suppose, don't use metal pipes wherever you can, and especially not lead. Got it. But honestly, the problem I guess I have is, well, where were the engineers, the chemists, and the biologists in all of this at the Flint water treatment plant? I spent a decade in water and wastewater, and periodic sampling at treatment plants happens daily, weekly, monthly, and at reservoirs, there are key sample points in the network, customer premises. You name it, they test it. Originally, every plant I worked at had its own laboratory. They would test their own water samples from their own local reticulation network and reservoirs. And in one plant, we had a SCADA client in the corner of the lab, and I remember the sound of the centrifuge spinning up and down as they ran tests on that water. I mean, they centralized them now so they could afford better test equipment, and they've cut the number of chemists on the payroll, I'm sure, but hopefully not too few. But to not understand something like corrosion, that's fundamental. Absolutely fundamental. To switch water sources and not to understand the balance the water needs to have in its chemistry in order not to destroy your pipework infrastructure that you need to deliver your water to your customers is frankly, it's ridiculous. It's criminal. You're entrusted not just with taking care of an asset. That pipe in the ground is an expensive asset. And beyond that, the entire city's population depends on that to survive. Their health, their well-being. And in an effort to save money, it's cost an immeasurable amount more than that in the long run. And let's not even think about the lawsuits and the class actions that it's going to cost them dearly in months and years to come. But beyond the money, it comes back to supervision and putting the right people in charge. There are people that blame Kurtz, Croft, and Johnson in varying degrees. There are others as well that are implicated. But with so much of that still under wraps and being closely guarded, it's difficult to know, at least today, for sure, who was pushing for the river water solution. Maybe we'll never know. Maybe there's enough hands in the ring that we won't be able to single out any one individual. But in the end, I suppose to me, it doesn't matter so much as about the individual. But it's clear, though, to me that the people that were entrusted to run the Flint water treatment plant and the water quality testing weren't qualified to do so. And if they tried to fix the dosing issues at the plant, there's been no evidence presented that I can find that they ever even tried. The wrong people were running the system. Clearly, they weren't supervised by the right people either. The wrong people were put in charge, and it didn't take very long at all for everything to completely fall apart. If you're enjoying Causality, and want to support the show, you can, like one of our backers, Chris Stone. He and many others are patrons of the show via Patreon, and you can find it at patreon.com/John Chidgey, all one word. Don't forget, if you're enjoying Causality, you may enjoy other shows on the Engineered Network, such as Nutrium, Pragmatic, and a new show, Analytical. Be sure to check them out too. This was Causality. I'm John Chidgey. Thanks for listening.